Okay, let's take a look at your homework on triangle ratios. Some of these were ratio problems and some of them were just problems that have to do with triangles. So let's just do them in order. Number one, in the diagram below of triangle ACD, DB is a median to AC. And that means that AB is congruent to BD. Oh, and also, so let's go and see what that tells us. Well, if AC, if DB is a median, that means that B is going to be right in the middle of AC, which means that AB will be equal to BC. And here it also says that AB is equal to BD. Okay, that's going to be helpful in this problem. Now let's see what else they give us. The measure of angle DAB is 32 degrees. What is the measure of angle BDC? So I'm going to put a little X here because that right there is the ultimate question. The measure of angle BDC. Well, let's see what we know about this triangle over here. If two sides are the same, that means it's isosceles, but it also means that the angles opposite the congruent sides are going to be the same, which means this will also be 32 degrees. And we know that a triangle adds up to 180. So if I take 32 and I add to 32, we get 64. And then if I take 180 and I subtract 64, we get 16. 116, make that. That means this right here is 116 degrees. Now, two angles on a line also add up to 180. So if I just do 180 minus 116, we go back to the 64, which means this right here is also 64 degrees. And this is also an isosceles triangle, which means that this side and this side are equal. Well, if I take the 180 again, and I take away the 64, you get, of course, your 116. But now we got to divide that equally amongst two angles. So 116 divided by 2 is going to be 58 degrees. This is going to be 58, and this is going to be 58. See, it's just a big little puzzle. Can't be both big and a little puzzle. All right, number 2. In the diagram below, isosceles triangle ABC, the measure of the vertex angle B is 80 degrees, and AC extends to point D. What is the measure of angle BCD? That's the angle that we're looking for right there. Well, if this is an isosceles triangle, that means we know that these two angles are going to be equal to each other. So if we take the 180 and we subtract the 80, we end up with 100. And then we divide that by 2, and you get 50 and 50. That means this is 50 degrees, and this is 50 degrees. Now, these two angles are supplementary. They add up to 180 because they're together on a line. So 180 minus 50 is 130 degrees. Okay, well, now we get really to the ratio problem. It says the three angles in a triangle are in a ratio of 2 to 3 to 4. Find the largest angle. Well, as we learned, when we separate the numbers in the ratio, we attach x to each one. And then we ask ourselves, what do we know about the three angles of a triangle? We know that they add up to 180 degrees. Well, we're going to divide both sides by 9. And you're going to get x is equal to 20. Well, we're now going to substitute the 20 into each one. 2 times 20 is 40 degrees. 3 times 20 is 60 degrees, and 4 times 20 is 80 degrees. So the largest angle is 80 degrees. Don't forget also, this is an acute scalene triangle. Okay, here's another one. These are really just puzzles. Just putting together the puzzle. Find the measure of angle ACR. That's the angle that they want us to find here. Well, we're just going to piece it together. Well, these two angles right here are next to each other on a line, which means they add up to 180. So if you take 180 and you subtract 125, you get 55. Well, I know that these three angles inside have to add up to 180. So I take my 60 plus 55 and I get 115. Well, I take my 180 and I subtract 115 and I get 65. And then the angle I'm looking for is the supplement of the 65-degree angle. So we're just really going to go back, and that's going to be 115 degrees. Number 5. In triangle LMO is isosceles, this one right here, with LO and MO being the same. Okay, if angle L is 50 degrees, and all right, everything else is given there, and find the measure of angle N. Here's our ultimate goal right there. Well, if this is isosceles, and these are the two sides that are the same, that means their opposite angles have to be the same. So if this is 55, this also has to be 55. Well, if that's 55, this angle right here next to it has to add up to 180. So if we take 180 and we subtract the 55, you end up with 125. And now we have three angles in a triangle that all have to add up to 180. So you have your x plus 28 plus 125 is equal to 180. X plus 153 is equal to 180. X is equal to 180 minus 153. X is going to be equal to 27 degrees. There. Another ratio problem. Find the angles of triangle ABC. They're in a ratio of 8 to 3 to 4. That's attaching x to each one. Add them up, 12, 15x, and set it equal to 180. Divide by 15, you get x is equal to 12. What's the smallest angle? Well, the smallest angle is going to be 3x. Well, 3 times 12 is 36. You can find all of them, why not? 4 times 12 is 48. And 8 times 12 is going to be 96. Oh, look, it's an obtuse scalene triangle, but the smallest angle is 36 degrees. Well, here's another 2 to 3 to 4. I think we did one like that already. 2 to 3 to 4, we did. X, we got 9x is equal to 180. Divide by 9, x is equal to 20. 2 times 20, 40. 3 times 20, 60. 4 times 20, 80. What's the largest angle? 80 degrees, right there. Oh, a 3 to 5 to 7 ratio. Find the largest angle. Okay, we separate them. 3, 5, 7, x, x, x. Oh, it's just like the other one as well. 15x is equal to 180. Divide by 15. X is equal to 12. What's the largest angle? Well, the largest is going to be 7x, 7 times 12, which is 84 degrees. You can find all of them if you want. 5 times 12 is 60. 3 times 12 is 36. Another acute scalene triangle. And here, these are all just puzzles here. AB is congruent to AC, which means that these two angles here, opposite those sides, are going to be congruent. This is going to be 40 degrees. Well, 180 minus 40 is 140. Cut it in half, you're going to get 70. and 70. But they want the measure of angle ACD. ACD. They want this one right there. Well, we know those two angles are supplementary, so it's just 180 minus 70, 110 degrees. And finally, here they show us a picture. One of the sides is extended. They want to find the measure of angle B. Ooh, this is one I don't think I taught you all. That's why I've been doing these the long way. Well, here, this one here is x. That means I can't put that x there. Sorry. And the measure of angle B, it says, is 2x plus 15. Sorry, 2x plus 15. Then it gives this angle out here, ACD, as being 5x plus 5. So here's what I didn't teach you, which is why I've been doing a lot of these questions the long way. But I have to teach it now because it's the only way to do it. This is what we call an exterior angle. It's outside the triangle created by the extension of one of the sides. This angle and this angle are interior angles that we call remote interior angles because they're not the angles next to the angle that's exterior. Well, there is a formula that says if you take the two interior remote angles, the x plus the 2x plus 15, and add them, you're going to get the other exterior angle, which is 5x plus 5. I didn't teach that to you, but I put these here anyway. All right, bring this here. 3x minus 5x is equal to 5 minus 15. Negative 2x is equal to negative 10. Negative 2. X is equal to 5. But they wanted this angle here, angle B, which is 2 times 5 plus 15. 10 plus 15, which is 25. There you have it. That's the homework. I don't think I'll put some of those harder problems won't be on the exams because I didn't really teach them, but these questions on ratio most certainly will. Well, I hope you found this video useful, and please bring any questions tomorrow and to next class.